Alright, so today is February 25, 2016, which is the day that we were supposed to turn in these personal projects, but we had a snow day today. So I'm not really sure um, when the actual date is going to be, whether it's going to be next Thursday when we have class again, or if it's just going to be tomorrow somehow during the day. So I'm taking this video so that I can email it to wherever I need to turn it into, just as proof of completion until I can bring the whole thing into school, probably next week, Thursday. So, yeah, I'll just kind of go through the code, I guess, and show what they do. So, this is just a pretty, it's a test. The title up here is IK test. Let's inverse kinematics test. So, all of these things here don't do anything. That's just showing where everything needs to be plugged in. So here it's gonna use code from the MeArm library and the Servo library. So it's attaching the all the servos to these pins on the Arduino, and then up here it just shows which wires to plug in where. Um, so then here's where we get to the real stuff. So this stuff just opens and closes the claw 3 times in a row, just so, like it says here, it's obvious that it's working, because some programs you upload it to the Arduino and then nothing happens and you don't know if it's working or not, if there's any kind of delay or something. So it does that, so you know that it started, and there's a short delay. Then it'll go up and to the left, close the gripper, and then goes down like almost to as far down as it can go, and then it moves to the right so that the arm is centered on the base, and then it opens the claw, and then it'll go back up to the start, and then there's a bit of a longer delay, and then it goes back and loops around. So I'll just upload that a second and show what it does. So okay, there it goes. So there's up and to the left, down and to the right. There's the clapper thing, and it'll just keep doing that. So yeah, that one is pretty straightforward, I guess. So it works. All of them work. All the servos. The code works well. The wires are slightly less of a mess now, but I've got something in the works for transporting it, and also that'll just be like it'll all kind of look nicer and be more aligned, I suppose. So yeah, there's that. I also have this 6-volt lantern battery to power it now, so I can power obviously all 4 servos at once. So yeah, that's that program. So then the other one, the main one that I've been working on, is this one. So it's got the same thing here, just a little info about the instructions on how to work it. Same thing here, where everything's plugged in. Everything is the same servo-wise, except that I have this extra adapter here. So what this program does is it allows me to control the movement of the arm using this controller, which is a Wii Classic controller. So the adapter I was talking about is this here. So obviously the controller plugs into it, and then it just runs to the board. So black is ground, red is power, and then the yellows are the analog inputs. So that's just what all these extra things are here, where it says WeChuck. That's what those are. So it's gonna use code from the libraries MeArm, Servo, and Classic Controller. So the Classic Controller one, the way to see the different libraries is whatever the color is. It'll probably be a little bit difficult to see on the video, but the different colors for MeArm, blue is MeArm, and then orange is Servo, and then anything that has a CC in front of it will be for Classic Controller, because it's not a default Arduino library. So there's a bunch of people who have collaborated to make different libraries for the adapter. There's a couple of different adapters out there. I got the one from Adafruit, which is where I also bought the Arduino from, just so that it was simple and convenient for shipping and everything. So I don't really think it makes that big of a difference, the adapter to library. They're pretty cross compatible, I think. So basically what I did for the library thing was I looked at what other people had, and then I kind of synthesized it and came up with a blend of a couple different ones, just to make all of this look a little bit better. So in essence, what a library does is it allows you to use one word. Like here you can see begin is in orange, so that's from the Servo library. So it just begins, you know, with all the base, the shoulder, the elbow, and the gripper. Those are all the servos. It begins with all of those at these positions. So where it says begin, if the Servo library didn't exist, there would need to be several lines of code just saying, making them all go to this position. And then basically what the Classic Controller library does in this case is it allows me to put in these numbers as coordinates instead of having to write in angles, because the servos will by default just read angles. So the Classic Controller library just translates angles into, translates coordinates, excuse me, into angles that the servos can't read. So here it's just starting with the joysticks on the controller and the servos all at this position. And then after that it goes into whatever happens when you move the joysticks. So all of them, all the servos, will float at a value of 0. So they will move in increments of 5 units. My interpretation is that's just 5 clicks. If you look closely at the top of a servo, it's got little gears. I don't know, it's basically a gear. I don't know if you can really see that. No, but anyway, it's basically a gear. So my interpretation is that it's 5 little gear teeth of movement. So anyway, here they're all pretty much the same. So it says if the joystick on the left is going to the left, or the joystick on the right is going to the left, then it will move on the x-axis -5, so anything negative is going to the left or down if it's on the y-axis, and anything positive will be going to the right or up on the y-axis. And also the z, so forwards and backwards, but we'll get to that in a second. So if they go to the left, then it goes left, and if it goes to right, it goes right. Pretty self-explanatory. And then up and down, and also forwards and backwards. And then the other part is that the A and B buttons and also the shoulder buttons will open and close the gripper, and then the home button will go back to the starting point, so 0, 150. So it'll be close to itself, so it'll be close to the middle servo, so it won't be stretched out, and then it'll be up about halfway, I think, and then it'll be centered for the most part with the base. Yeah, and then there's just a short delay, a really short delay between commands, so that you can't just like spam a button and just have the servo die. straight away. So I will upload this and show that it works. It takes a second to go when you switch programs, especially this one, since there's actually a lot of code. I mean, you can't really see it, but yeah, everything that says CC is from a library. So yeah, if I need to show that, I will go back and show all of those in another video. So here we go. Let's plug it in a second. It's a little touchy. There we go. Okay. So these here are just here for a counterweight because I don't really have anything better right now. Eventually I think the battery will probably be able to fit there, but so let's see, how can I do this? Okay, so we're just gonna reset this second. Okay, so this is the starting position. So that's what I meant when it's close to itself. So it's like up here instead of out there. So if I move this to the left, it goes to the left. If I move it to the right, it goes to the right, and then up. So that'll go forwards, and then backwards, and then the other joystick is what makes it stretch out, or I mean rather go up and down, like the gripper part of it, and then it can also make it go left and right. So I can, it's a little bit difficult to do this one-handed, but yeah, so there's the thing opening and closing. So A closes, B opens, and then the shoulder buttons, I was talking about these, will also open and close. So yeah. I mean, they're all the servos are plugged in the same places on the board, just for simplicity's sake, because it didn't really make sense to me to have to move them unnecessarily. So I can just leave all these plugged into the same. So all the other ones are going back to the actual servos. The black wire goes over here to the breadboard, that's the ground. And then red and black over there are positive and negative to the battery. And then all of these pairs of green and orange are going to the servos. So yeah, also it's plugged in there to the USB on the computer so I can upload the programs. Yeah, so I'm planning on having it pick up these somehow. These are called brain drops. So they come really small, and you stick them in a bowl of water, and then they soak up water. They get a little bigger than this one though. This one's been sitting out for a while, so it's a little bit dried out. But I think it'll be able to do that. I just have to put it on something, like a little board or something underneath, so that it can actually reach them. And then it's gonna, for the demonstration, hopefully be able to pick it up, stick it in a catapult, which I have here, and then I'm not sure, it might have enough torque to launch the catapult, otherwise I might have to help it a little bit, but that's just for the during the day expo, because I feel like after talking to Mr. Tyndall about it, 7th, 8th, 9th graders will be a lot more interested in launching projectiles than looking at the code for this robotic arm. Anyway, yeah, that's pretty much all I have for now. I guess I'll probably end up making another video or something going more in depth on the code, since that's the main project here. I'm just not really sure how much I need to say for that. I mean, yeah. I guess I'll just end it here, and just make more if I need to.